To begin, thank you very much for attending this presentation. This presentation it is called In-situ data collection for accumulated metal concentrations at the Thames Branch, Savannah River. This is a Department of Energy environmental management site. The collaborators present are the Savannah River National Lab, the Department of Energy, the Applied Research Center, and my department, the occupational, environmental and occupational health. So let's start by asking, what are accumulated metals? Metals are also they can be called metalloids, heavy metals, accumulated metals. They tend to refer to any a metallic chemical which relatively has a high density. Usually they cannot be degraded or destroyed. Metals are that are affected in this case are usually tend to affect negatively on people's health. Particularly, not all metals are bad. Metals are necessary to support life. As we go through this presentation, we're gonna experience how significant metals do affect adversely affect the health of the community. Some examples of metals are lead, copper, mercury, arsenic, cadmium. Those are some examples. A little bit of a background. This field study was conducted at the Savannah River site. This is in Aiken County, South Carolina. Usually the construction initiated around the 50s because of the Manhattan Project. This was a project initially to supplement and provide fuel for the development of nuclear weapons. Like I said, it was built in the 50s, and his main purpose was the manufacture of plutonium, uranium, and tritium. After the 50s, a little bit later than that, it was used for space exploration and for the production of nuclear fuel. After post-war, the environmental remediation group took over. The production ceased. EPA took over, and the same likewise did with his regulations. The DOE Environmental Management Group is well known and in his remediation projects, and today it's the largest environmental organization involving remediation. I did not mention, but the Savannah River site has around 310 square miles of area. The aim of the study was technically to gather data and to analyze the metals in the surface water of AO14 outfall towards the Thames Branch stream. This is a stream that pretty much it has outfalls of water, and they flow down Thames Branch to the upper three runs to the Savannah River. So it's important to differentiate all these confluence points because if there's a chemical of a high concentration, it's gonna tend to percolate downstream. The chemical results will be to determine whether there are higher level norms from the EPA. It could be from the FDA, higher level norms. So we're gonna in this scenario, my team and I, we not only accumulated data for the heavy metals, but we also did flow measurements. We are developing a hydrological model to determine resuspension of sediments, and sediments do tend to have chemical concentration, so this is important because it tends to flow downstream and may potential cause health harm. My scenario itself is water quality analysis. I'll be measuring water quality from from confluence points of the upper three runs all the way to the outfall. This is a nice way of depicting if you want to do a health hazard assessment. So it's pretty good to do that. Continuing forward. Before anything, we did conduct preliminary training at the FIU Preserve, also at the Tamiami Canal. We gathered flow data, we gathered YSI data. In particular, I was in charge of YSI. This is a multi-parameter handheld unit. It's military grade. It's very easy to use, as versatile. They did give us enough information, the instructions of how to use it. I was instructed, particularly in this machine, how to calibrate the machine, how to log data, how to extrapolate data from it. We did follow USGS protocols in how to calibrate the machine and how to collect data samples. So you will see in the PowerPoint how it's depicted, so it's very easy to understand. The methodology for the YSI 556 multi-parameter. We did collect, our main focus was to collect more than 10 sample locations in AF14, starting at the confluence points of upper three runs all the way upstream to the outfall. The reason was we didn't want to disturb the system, so that's the methodology that we created. We wanted to collect samples, we said 10, so we wanted to collect at each sample 3 bottles of 30 ml containers. And I don't think I've previously said, but the YSI 556 records salinity, dissolved oxygen, pH, conductivity, total dissolved solids, temperature. We did have to collect elevation, UTM coordinates, but that was done by a GPS handheld unit. The multi-parameter had a wire at the end of the probe. It had sensors which detected all these things that were highly sensitive, and I did conduct data collection by both ways. One was manual. I used a notebook, and the other I used a digital log, which it was easily USB plug in and play. But I wanted to keep a safe side and have two sorts of data collection. Also, since we collected water samples, we had a methodology of how the instrumentation for the sampling in the laboratory. We had since we collected samples from each location, we separated them, and we categorized them as filtered, unfiltered, and acidified. We poured 10 ml into each test tube. We labeled each sample with a sample ID and the location we gathered. Since we did filter them, I filtered them through a 0.2 micron pore diameter member filter. And since we did acidify them, we used nitric acid with a pH lower than 2, so it doesn't precipitate in the ICP-MS. In order to gather some data, we needed to analyze and pre-concentrate the techniques used, since most of there are some parameters of concern that needed fluctuation points. So we got some help from the scientists there in order to get those accurate results. In the PowerPoint, you would see my result analysis. I created tabular data with the sample ID, the northing, easting, the UTM coordinates. It gives you the elevation, the time, dissolved oxygen. Even it gives you the pH with the conductivity itself. It's very simple. It's very neat to see your data all organized and easy to pick up or to analyze. As for the results for the ICP-MS, we did gather a lot of heavy metals of concern: manganese, magnesium, iron, nickel, copper, zinc, selenium, lead, uranium. Those were some of of the heavy metals of concern. The MDLs, there's some of them that are minute numbers, so the machine wasn't able to pick up those numbers. So in other words, they weren't of concern. If you look at the PowerPoints, I've selected four of them that, in my opinion, those were relevant, and they need to be taken into consideration. It's very simple: filtered, unfiltered. So some more analysis. I've actually given a brief description of how, since the YSI gave an idea of how dissolved oxygen and its saturation in fresh water. There's some literature that does suggest that the comparison of dissolved oxygen with temperature does give some indications whether there is a clear possibility of biota present or not. Since there's low oxygen present at TIMS branch 1.1 in this case, you would see that there's a low concentration. You would have a lot of phosphorus deposition, making it prevalent for fish and birds to eat, and as you would continue further, they would eat that, and it would bioaccumulate, so it would go back into the life cycle, and it would definitely pose a health hazard, since the fish do eat it, and we do eat the fish. Other data parameters I've depicted there are higher concentrations of iron, even though it's not considered a health hazard. I have shown it, and I have depicted where exactly it's highest in concentration. My results, basically, my thesis statement was some data parameters were going to come out higher than EPA norms. And not only I've checked EPA, I've checked the Agency for Toxic Substances and Disease Registry. I've checked the FDA and its regulatory limits. The ICP-MS gave me some data parameters in micrograms per liter. So far, the highest concentration is iron, ending all the way in lead. We did study multiple water plumes for the accumulated metals. So in relation to that and his adverse health effects, let's talk about the routes of exposure. We have I'm in my third semester, going through public health, so meaning that we have seen in several of our courses the routes of exposure, how it can be penetrated by a series of barriers, thanks to the ingestion, the inhalation, the absorption, or it can be injected. Personally, I was aware, and I was witness of hunting. I was witness of recreational activities, fishing, kayaking. I saw people bathing. So, like I said, this is a watershed that it's not very navigable, but you definitely see some interaction with point source effects, all the way leading to confluences where major tributaries are affected, and they do interact with the public. Let's start with mentioning, like I said, I've given out, I think, 9 or 10 heavy metals of concern. Most of, like I said, iron was on my top list. So iron is considered a carcinogen. The effects of iron are usually consisted of bad taste. It tends to clog the pipes, and it tends to stain teeth. The median concentration from TIMS branch itself was a 0.7 megagrams per liter. Other concentrations led all the way to 10 megagrams per liter, but it was sometimes found downstream. As for magnesium is also a carcinogen. It appears to influence mortality in people with cardiovascular disease, and it tends to feel water tends to feel hardened, so that's a good indication that it has a high concentration of magnesium. There's been investigations of epidemiological research that do suggest that it does possess a risk for cardiovascular disease, growth retardation, and other reproductive failures if you have a high concentration of magnesium in your diet. We all know how arsenic does affect um, our our way of of seeing. We do see it in the media. Arsenic levels are high. Arsenic, inorganic arsenic, is a known carcinogen, and it tends to cause cancer in skin, lungs, and liver, especially in the bladder, since that's how the way we excrete it. Lower levels of exposure tend to cause vomiting, decreased production of red and white blood cells. It tends to cause our normal heart rhythm. And arsenic is a well-known teratogen, so it does affect fetal reproduction. Lead, we see lead in the paint and whatnot, but lead is present in this watershed. Lead is also known as carcinogen. It can affect the organ system. Lead is mostly prominent in in the nervous system, how it affects it. It severely affects how the brain develops. In this case, in women, it can cause miscarriage, and is also a leading cofactor of teratogenic effects. Zinc, in this case, induces tumors, but is not a carcinogen. High levels of zinc in several months, if ingested in your diet, can cause damage to the pancreas. Decreased levels of high density lipoprotein cholesterol. That's the good protein, the good cholesterol. So it tends to lower the good cholesterol, and that's not necessarily a good thing. Um, if ingested more than 5 milligrams per liter, you tend to have a bitter taste in your mouth, and it may cause nausea and vomiting. When in manganese, if you look at manganese, it was present at the watershed. Manganese is considered a carcinogen. If you look at it at the large scale, manganese can cause headaches, apathy, irritability, insomnia, and sometimes weakness in musculatory movements. And long-term manganese exposure tends to have nervous system disorder. Aluminum, in this case, is not a carcinogen. It was present at the watershed. Aluminum tends to be more of an exposure via injection. This is where you would see something like in children. Children do get vaccinated more often. So aluminum is an exposure route through via injection. Um, if exposed in high levels, it can affect your health. People with kidney disease tend to have sometimes develop bone and brain diseases that it can cause by the excessive aluminum. Also, an important and nice article that I read based on literature. Studies do propose that aluminum does cause some sort of Alzheimer's disease. I read it in two articles. It's not very. I haven't double checked on my my facts, but it was interesting to see. And we do know that aluminum does affect reproduction on people. That's for sure a fact. Nickel, in this case, is a well-known carcinogen. The exposure routes is through ingestion, skin contact, the bathing. Most harmful effects of nickel are allergic reactions. You do see people that work on jewelry; they tend to have these allergic reactions. The powder does cause asthma attacks, and some people are very highly sensitive to nickel. Um, in this case, eating and drinking large amounts of nickel has caused lung disease based on literature. There's been studies on rats, on dogs, that has also caused stomach and blood liver and kidney immune system malfunctioning, and also there's been data that suggests also in rats and dogs that suggests that there's malfunction in reproduction. Let's see what else. Tin. Tin in this case was present. Tin is not a carcinogen. Um, Exposure of tin can be through the uptake of water or bioaccumulated seafood. It could be through shellfish. It could be through. In this case, I did go to a restaurant when I was there, so I did encounter them in the menu. They have turtles, so you can you can't eat turtles. You can't eat mussels. You can eat certain type of fish. Catfish is like their well-known fish, or like a local fish. They have bass. Um, Usually, mostly the chemicals associated with bioaccumulation, they tend to associate in the gills of the fish. But there's been a lot of literature that I've read that human and animal studies show that large amounts of inorganic tin can cause stomach ache, anemia, liver, and kidney problems. So a lot of the stuff is it's related. So imagine if you have all these heavy metals present, and in the place that you're mostly working or having your a fun time or eating or fishing or something, you might want to be aware of all these things uh, that are um, that are prominent in that area. Uranium, it's well known that it's present there. Depleted uranium itself is a well known carcinogen. Um, Uranium is basically everywhere in the world, most prominent in sources where there's minery, where specifically people that are living next to nuclear reactor sites. So you're going to find depleted uranium there. Um, Uranium tends to go into sectors where there's a lot of plant life. And like for example, if you were eat a potato would contain high amounts of uranium since all the roots extract all the uranium concentration of it, tends to bioaccumulate, and it tends to stick, like I said, to vegetables, and it's directly related to the uptake that we eat. Since we do ingest all that food, we are in some sort correlated, and we have some sort of correlation of the uptake that we do ingest that. So all of that is related. Copper, last but not least, copper. Copper was present. It is not considered a carcinogen. Um, Basically, there's been studies that do say literature does suggest that a high level of copper does can cause respiratory malfunctions and nausea, diarrhea. Very, very, very high concentrations of copper can cause liver damage, kidney, and even death. Um, Pretty much exposure routes are through the water, drinking, eating the foods, having skin contact with copper particulates. It's very prominent. If you would see the presentation, um, it's very neat. I was lucky enough to go in this field sampling analysis. Um, we will do some more. Hopefully, we're trying to get funding from other outside sources, but it's very neat. Um, we have, like I said, we're in the public health sector. Most of our environment is it's it's well correlated that our environmental factors do affect our way of how diseases work. If you look at the genomics of it, how these chemicals and how these elements do affect our immune system, how they affect our if whether we're obese, whether we are have asthma, all those things are valid reasons to have this interpretation of what I'm giving you, to have some sort of an idea that is very important to have this prominent in your lifestyle. Um, the discussion and conclusion of this sampling analysis was that, in summary, an average daily combined exposure levels that we saw daily of the accumulated metals, we did see a higher concentration of arsenic and nickel at higher acceptable levels based on EPA, FDA, and Agency for Toxic Substances. Um, it's important to understand that since these metals have the capability of binding to estrogen receptors, not just that, they actually mimic the actions to physiological estrogens. Um, it does serve a significant, in my opinion, since I am highly involved in this subject. I do possess that this is a significance that it can pose a risk to public, given the fact that people are drinking the water, since the water is pumped out from wells and it's even filtered from the surface water themselves. It's even used for cooking, for bathing. I saw a lot of people swimming. Um, it's important to suggest that we need more support. And like I said, we're trying to get more funding, and we're trying to write abstracts in order to develop more ideas of how we can incorporate this into future research. Um, in my opinion, the strengths and weaknesses, we did use a lot of past statistical evidence, inferencing historical data. Like in my opinion, in my perspective, historical data was available from EPA, from a lot of sources, but it's not like actually going to a field and seeing real time data. This is a highly secluded place, highly restrictive. We did get escorted everywhere we went. Um, we had escorts even to step out to the car. This is a site that is highly secured. Um, the objective was achieved. We achieved more than we expected, but we were uncertain that we were going to make mistakes, since of course error and bias always affect your sampling. Um, in my opinion, our next field study would definitely have a more precise standard operating procedures. All of this is to minimize bias, to collect data correctly, to maybe not write all those tables inside, to actually have something already printed. Um, all the instrumentation, it's we did a great job. Our team did a fantastic job. We got data for to calibrate our hydrological model, and this model itself would be all a tool to predict whether during an extreme event, all these chemicals and all the sediment can be resuspended, and it can be, percolated downstream. So it's important to associate and to actually interpret this data in the right scenario. How we eliminated errors in the study design. We created a methodology in order how we felt more comfortable with the study. Our collection, whether there's sometimes that it rained, there's sometimes that it was highly vegetated. We had to carry a lot of instruments with us, so our collection had to be precise, and um, we couldn't not collect the right amount of data. We would not be able to leave if we didn't collect that data. If you look at the processing system of how I did my analysis through YSI or ICP-MS, if my machinery, if I did the right job in calibration, or if the machine itself there at the lab was calibrated, whether my instrumentation, whether my methodology was precise, whether if I spiked my samples correctly, whether if I put the right acid amount, all those are parameters that need to be taken into consideration. For sure, I'll take them into consideration during my next field study. Um, Negative or positive errors in your analysis can be either signs of contamination. All those things are very important to take into consideration. Um, Recommendations. Um, Basically, just improve my results. There's a lot of things that I wish I could have done. Um, yeah, I just we were lacked in time. Definitely, I'm gonna do additional trainings. We could have gone and taken soil samples, but we couldn't. We didn't have the right protocols. We didn't have the right badges to collect soil samples. A lot of the stuff the scientists there don't like to disturb, since they're scared of resuspension, and they don't want the site is considered somewhat remediated, but they're afraid of a 100-year meteorological event, and everything's gonna be washed out. So that's what they're afraid of, and that's what we're trying to monitor. For future work and implementation, I couldn't emphasize this more. Um, how to collect your samples, to collect soil samples. I'll definitely look into that. Other ideas that I have, in my opinion, um, I'm trying to focus on the study of metalloestrogens present at the watershed. I feel like I have enough data to incorporate and create a nice abstract. I have been working on it, and I also would like to study the biota present and how the accumulation uh, takes place of how, let's say in plants, of how much evapotranspiration does affect, and maybe implement a model to get all those parameters together, especially my water quality, my ICP-MS, and all that, to get a hydrological model with soil and sediment transport together, or maybe an exposure assessment. I'm definitely working on that. But yeah, guys, like I said, this is a very different thing for me. I was introduced to this. Most of the stuff I had to create on the spot. I hope you guys liked it, and if you have any questions, you're more than willing. You can email me, or you can find out how I got here, or how I was introduced to all of this. But hopefully, you guys are interested in my research, and yeah. In the PowerPoints, you can see most of my references, and I gather most of my stuff from PubMed. I love PubMed, and FDA, the Agency for Toxic Substances, as well, from EPA. And yeah, thank you so much for your time, and hopefully you enjoy this. Have a very nice evening. Thank you, guys.